the shape of a distribution. So if we look at this first diagram here, it's symmetrical. Okay, if I put a dotted line down the middle, and if I fold on that dotted line, the left-hand side there would be the same as the right-hand side. That is a symmetrical distribution. So the shape of a distribution. Now, girls, pretend that there is a column graph or little dots underneath here showing all the scores. Okay, do you get what I'm saying? So there could be columns under here, there could be dots under there. But if I did draw a line, like for example down here, this is not symmetrical. See the dots, and you draw a line like that? So this first distribution up here is symmetrical, and it is symmetrical if the data is balanced, evenly spread about the center. So if it's symmetrical, the mean will equal the median, which will equal the mode if it's symmetrical. Okay? Now, this one here, this distribution is called positively skewed. Look, a lot of people forget how to recognize positively skewed or negatively skewed. One year a student said to me, start off on a positive note. See how all the data is at the beginning and less data is at the end. So that's positively skewed if most of the data is at the lower end. I know that sort of is a bit different to the number line, but start off on a positive note. So positively skewed is if the tail bit here is points to the positive direction. You know how that's the positive x-axis? You know how if I had an axis, aren't these the positive numbers over here and these are the negative numbers? So if the tail points to the positive end of the x-axis, do you get what I'm saying? Like these numbers might be 1, 2, 3, you know, -1, -2. Positive is to the right always. You know, when we talk about up is positive, down is negative. To the right is positive, to the left is negative. So the tail points to the right, so that's positively skewed. Or you can say start on a positive note. With positively skewed, the mean is above. Just pretend this is an axis with numbers 0, 1, 2, 3, 4, whatever. The mean would have a higher number than the median and the mode. Here, if, like the mean might be there, the median and mode might be lower down. See, the mean is a bigger number. If it's an axis, remember down here, pretend there's a column graph underneath it and you've got columns. Wouldn't there be a bigger number underneath this column with the mean? Do you get it? All right. Now, look, I don't learn it like that anyway, the mean being bigger than the median and the mode. I just learn the shape. Start off on a positive note, or the tail is towards the right. Sorry, for positively skewed. Now, for negatively skewed, it's the opposite of positively skewed. So the tail is at the beginning and most of the data is at the top end. So the tail is to the left, which is in the negative direction, and most of the data is up the top end. And with this, the mean will be, the average will be less than the median and the mode. All right? Now, clusters, we're just looking at what a cluster is and what a peak is. So, positively skewed, I don't know if that thing is very clear, but it's like this, all right? Like that. And negatively skewed, the tail's first and a lot of the data is at the end, so the tail's first, all right? Now, peaks, obviously that's a peak. These are peaks there. The high points of the distribution, and they are often, you know, where your mode and things like that is, all right, or are. It represents the more frequent scores, and the highest peak is the mode, and clusters is where you've got lots of groups of scores bunched all close together. So let's look here at some questions from the exercise. It is negative, like it's pretty much that shape. Most of the data is towards the end, okay? It is sort of, I know this goes up here, but just ignoring that. If you ignored that and that sort of went down, a lot of your data is not at the beginning of this graph, it's at the end of the graph. Do you see that? A lot of the data is at the top end of the graph, or the tail bit is pointing to the left. We're not starting on, I think of it as positively skewed, it's most of the data is at the beginning. Start off on a positive note, right? Most of the data is not at the beginning, it's at the end, at the higher numbers. Do you see? So this is, it's negatively skewed.
Okay.
Okay?
So Miss, when they ask you to describe the shape,
You just say positive.
Yeah, so when you're asked to describe the shape, you just say positively skewed or negatively skewed. This is definitely negatively skewed, and it's got one mode, which is 8.
So it's not like the other subjects, we have to be like strong correlation. You just said
With a stem and leaf plot, the best way to see whether that's positively or negatively skewed is to turn it sideways. Now, look at that, positive or negatively skewed. Yeah, the data's not at the beginning. We're not starting on a positive note. That's negatively skewed. Because the bigger numbers, see, the bigger numbers. So for a stem and leaf plot, turn it sideways to see if it's positively or negatively skewed. Just some questions. How many stores were surveyed? What would you do? Add up all of these. You know what I would do? I'd just add those up. 1, 2, 3, 4, 5, 6, 7, 8. That's 16 there. And 4 is 20, 23. I think that's another 10. 33. I think it's 36. Did you get 36? All right. The shape. What's our shape? So it's negatively skewed, and you can tell that by turning it sideways. Where does the clustering occur? Yeah, it's in the, so yeah, in the 70s and the 80s. See, they're the two biggest, highest columns. So the clustering is in the 70s to 80s. So clustering in the 70s to 80s, and the mode, you don't go for a particular column, you need a particular score. Well, there's 4 8s there. Yeah, it looks like 88 for the mode. All right. We're just going to do another 2, and then we're going to look at a HSC question, all right? Now, some of the HSC questions with shape we'll be looking at further down in the topic. It's just that they're combined with other things. You don't often just get a skewed question on its own. It's often with something else. All right, having a look at question 5. All right, you know the first graph. How would you describe that one? Symmetrical. That first one is symmetrical, definitely symmetrical. Because if I put a line down the middle and looked at either side, it's identical from the middle. That's how you can, so this one, even though it's not asking, but this is definitely symmetrical. Because if I look at the middle of the data, which is where 5 is, see 2 dots, 2 dots, 2 dots, 2 dots. That's symmetrical. What about this one? If I do my little line over the data, what's that? Yeah, negatively skewed. So what have we got? Actually, that's not one of the answers. So Y is positively skewed. That's not right. X does not have a mode. Oh, that's true. Yes, that's the answer. All right. Do you really think that the average of Y is going to be 5, the average of these numbers? No, it's going to be higher than 5. Most of the numbers are 6. I wouldn't be surprised if it's over 6. 6 point something for sure, the average there. And they're not both symmetrical. All right. So this is sort of negatively skewed, this one anyway. All right, question 7. Just have a look. Just try the next 2 and we'll go through them in a minute. 1. Yeah, it's positively skewed. Just. So positively skewed. Now this one's looking at, you know, with positively skewed, it's really hard to remember if the mean's bigger or smaller. It's quite hard to remember that. But I'd say the mean should be smaller if most of the data's at the beginning. B, they're asking for the mode. What's the mode?
3.
Yep. And now the mean, the easiest way to work out the mean, you know, is the sum of the scores over the total number of scores. So sum of scores over the number of scores. What's the quickest way to add up the scores? What do all the zeros add up to? I've got 2 1s, they add up to 2. Do you get it? My 2, that adds up to 2. What about the 3s? What do they add up to? 3, 3 and 3 is 9. That's the best way to do it. 4 and 4, 8. 5 and 9. And then you just add up the numbers on the top. So you add up all the 1s, you add up all the 2s, you add up all the 3s, etc. This is like, you know what I'm writing up here? It's like your FX column. It is like your FX column in a frequency distribution table. So what do they all add up to? 35? Yeah, no, we count the dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
Why am I done?
Now, wait a sec. 12. This dot plot represents the number of accidents per month. So let's just read what this means. Accidents per month, 0. So there were how many months where there were no accidents?
3.
2. How many
I
months?
get it. Oh.
This dot plot represents the number of accidents per month at a factory over the years. So in January, how many accidents? In February, we don't know which month's what. But in 2 of the months, there were no accidents. In 2 of the months, there was 1 accident. Do you get it? In 1 of the months, there was 2 accidents. In 3 of the months, there were 3 accidents. In 1 of the months, there were 9 accidents. No, there were no data there. So, no, there was not a particular month of the year that had 6 accidents. There was not a particular month of the year that had 7 accidents. So it's really important when you see these that you read it, that you know what it's talking about. All right, the number of accidents per month. So January, there were so many accidents. February, so they plot them. We don't know which month's which. All right, so there were no months where there were 8 accidents. So, yes, that's why there's 12. So the mean is 35 over 12, should be 2.9 something. 2.916 recurring to 1 decimal place, average 2.9 accidents a month. Notice the mean is just slighter than the modes, just slightly smaller than the mode. All right, and just there was a multiple choice question from 2006. Positively now, standard deviation. What does what is a smaller standard deviation? What does it mean? Is bigger or smaller? Is a smaller spread out of scores. So standard deviation means how spread out the scores are. So you want positively skewed with a smaller spread out of scores. Show me the 2 that are positively skewed.
C and A.
Yeah. So this is negatively, B is negatively skewed, and so is D. So it's between A and C. Which one has a smaller spread of scores? Here onwards, don't you think there's more data under there than there is sort of same place on the scale here? It's got less data there. So this is a smaller spread of the scores. I know it still has the tail, but most of the scores are closer together. All right? So C has a smaller standard deviation because most of the scores are more bunched up. The more the scores are bunched up, the smaller the standard deviation. Okay?